In section 4.6, you're going to be solving equations. So ultimately, you want to get down to where you find the value for the variable given. So with exponentials, you are going to be trying to get like bases. And when you get like bases, so in this example, we have a to the m equals a to the n, then you know that you're going to have m is equal to n. So for this first example, we have 1/3 is raised to the n minus 8, and then we have 3 is raised to the 4n minus 2. So we're going to rewrite this as 3 to the negative first power. And then we still have our n minus 8. And on the right side, we still have 3, and it's raised to the 4n minus 2. So I'm going to distribute that negative to both of those terms. So I'm going to have negative n plus 8 is equal to 4n minus 2. And then we solve this for n. So we get 5n is equal to 10. And n would be equal to 2. So these are easier kinds of questions. They're going to get progressively harder. So if like bases are not possible, then we're going to be using a log or a natural log on both sides. This is the mistake that kids will unintentionally make, and you're going to bring the variable out of the exponent. So in this one, I can't write 50 with a base of 2. So I'm going to take the log or natural log, and it does not matter which one you use. Okay, so I'm prone to use natural log, but you have to make sure that you do it to both sides. So what this does for us is from the properties, I know that x comes out here. So this is x times the natural log of 2. And at any point, you can change these into decimals, but you don't have to. So the natural log of 2, I know, is going to be a decimal. So we're going to divide on both sides by that number. So when you type this in on your calculator, you want to make sure that you're using using parentheses. So this answer will give us 5.64385,619. In the next problem, you cannot get the same bases on both sides. So we're going to take the natural log of both sides of the equation. And the one on the right is the one that we sometimes will forget to do, this one right here. So be careful that you do remember to do that. So what this does for us is to bring this forward. So we have 3x minus 4. And then we're multiplying that by the natural log of 4. And that's still equal to the natural log of 31. Now, you've got a couple different ways you can finish this question. Usually, I tell kids to go ahead and distribute this. So you have 3 times the natural log of 4, x, minus 4 natural log of 4, and that's equal to the natural log of 31. So my goal is, of course, to solve for x. So we're trying to get this by itself. So we're going to add 4 natural log of 4, or you can change that into the natural log of 256. Because 4 to the 4th power is 256. And then this front will turn into the natural log of 64, because you can take the 3 up to the 4, and 4 cubed is 64. So we have this is equal to the natural log of 31 plus the natural log of 256. One reason I'm getting rid of those front numbers, this 3 right here and then this 4 here, is because we end up not really sure what to do with them. So if you just get rid of them, you don't have to worry about it. So then we are going to divide both sides by the natural log of 64. So when we divide by the natural log of 64 on this side, we get x is equal to. Now, as you type this in on your calculator, you want to make sure that you're using parentheses appropriately. In the next one, we also have something that we cannot make like bases. So we're going to take the natural log of both sides. And what that does is enable us to bring down the 7x. Now, the nice thing about this is the natural log of e is just the number 1. So we have 7x is equal to the natural log of 15. And then we divide both sides by 7. So when you type this in on your calculator, make sure that you close the parenthesis after the 15. So it will probably take that answer if you want to leave it that way. If you want the decimal, it's 0.38686431444. So the most difficult of these to work on are the ones where you can't get like bases and you have exponents with variables on both sides. So that is the case in this problem. This problem is going to take quite a bit of paper, so if you needed to move to a new page, I would go ahead and do that. So we're going to take the natural log of both sides. Now, doing this will enable us to bring down our exponents, and it's also going to give us a very complicated equation. So both of these are going to come out front. So we're going to have 6x minus 7 is brought out front. And then we have the natural log of 4, which also goes together. And then we're going to have 6x minus 8 and the natural log of 10. Now, there are many, many ways to do this question. In my experience, students like to go ahead and change the natural log of 4 into a decimal and then the natural log of 10 into a decimal. I don't do it that way, but if you like the decimal versions, then that's probably going to be best for you. What I'm going to do is distribute these natural logs in here. So I'm going to have 6 times the natural log of 4 times x. And then I'm going to have minus 7 natural log of 4. And then over here, we're going to have 6 natural log of 10 times x. And then minus 8 natural log of 10. And what we have to realize here is that we need to get these two x's on the same side and get everything else to the other side. So I'm going to leave 6 natural log of 4 times x over here, and I'm going to subtract this one to that side. So I'm going to subtract 6 natural log of 10 times x. Now, I'm going to add 7 natural log of 4 to both sides because that's just a number. And again, if you want to find that decimal approximation for that, you can go ahead and do that. So on this right-hand side, we're going to have 7 natural log of 4 minus 8 natural log of 10. So over here, these are just coefficients. Now again, some of you all have already changed it to decimals, so you know that you just combine the two decimals. So we're going to have 6 natural log of 4 minus 6 natural log of 10. And all of that is the coefficient on x. And then on this side again, you all probably have the decimal version of this on your paper, which is fine. So we would end up with this expression. So to solve for x, I just have to divide by this. So we're going to divide both sides by that. So we have x is equal to, on the top, 7 natural log of 4 minus 8 natural log of 10. And then we're going to be dividing that by 6 natural log of 4 minus 6 natural log of 10. And the parentheses are not necessary. And then, again, you all probably already have the decimal approximation, so let's make sure that we match on this. So in the top, I have negative 8.7166202.162. And in the bottom, I have negative 5.4977443913. So when we divide those, we're going to have an x value that's equal to 1.5854902.658. You need to make sure that you are careful on your calculator that you've gotten the appropriate decimal. So now we're going to start with your logs. So the first thing that you're going to do is make sure that you only have one log. You can have one log on the left side and one log on the right side, but you can't have any more than that. So we start off fairly simplistic. So for this one, we are going to change this into an exponential function. So my baby base 2 becomes big base 2. 4 is the exponent, and then we have x to the 5th power. So we have x to the 5th is equal to 2 to the 4th power is 16. And then we're either going to take the 5th root of that, or more easily on our calculators is to raise that to the 1/5 power. So x is going to be equal to 1.7411011266. All right, so the next one, again, we only have one logarithm, so we just need to write this as an exponential. Again, we have a baby base of 2, so that becomes big base 2. 3 is our answer, which means it's our exponent, and that's going to be equal to 5x plus 4. We know that 2 cubed is 8, so 8 is equal to 5x plus 4. When we subtract 4, we get 4, and that's equivalent to 5x, so x is equal to 4/5. So in this next one, it looks a little bit different because we have this front number out here. All right, that's being multiplied. So what we're going to do to get rid of that, since it's a fraction, is to multiply by the reciprocal, which is 2 over 9. So that means those are canceled. This is 2 over 9 over on this side. So that leaves us with log base 4 of x is equal to -4/9. So again, we only have one logarithm on the left side, which means that I will write this as an exponential. So I have 4, and it is being raised to the -4/9 exponent, and that's what x is equal to. So type this in very carefully. Make sure that you put parentheses on your exponent. So we're going to end up with x is equal to 0.5400298,694. So this is our last page of these examples for these equations, and these are going to be logarithms. And I've written you a little note up here that says if there's more than one log term on either side, any of the sides, then you must collapse them down to where you have at most one on each side. All right, so this first example, I only have 2 on the left side. I know that because this is addition, that I am going to end up multiplying this times this. So I'll have one logarithm, and I'm going to multiply x times x plus 2. So that's going to leave me with x squared plus 2x, and that's still equal to 8. So once I break it down to where I have one logarithm, that means that I'm going to write this as an exponential. So I don't see a base down there with the logarithm, so I know that that means I have 10 is an understood base. I'm going to raise that to the 8th power, and that's going to be equivalent to x squared plus 2x. So since this is quadratic, I'm going to bring it on out here so that I have room to work. I'm going to have x squared plus 2x, and then I'm going to subtract 10 to the 8th power, and that's going to be equal to 0. So that's not going to factor, obviously, so we're going to have to use quadratic formula, and yes, this is going to get very long, so be patient and make sure you have plenty of room to work. So you're going to have -2 plus minus the square root. 2 squared is going to be 4 minus 4 times 1 times -10 to the 8th power. And then we are going to divide that whole thing by 2 times a, which is just 2. So we're going to have -2 plus or minus the square root of 4 plus, now this is going to be a big number with lots of zeros. So you're going to have 4, and then you're going to have 8 zeros. And we're going to divide that by 2. So we're going to have x is equal to -2 plus or minus. So you're going to add the 4 to that number. So you're going to have 7 zeros, and then a 4 at the end. Now, when we take the square root of that big number, we get 20,000.0001. And we're still dividing that by 2. So that means we're going to have negative 2 plus that number. And we're going to divide that by 2. And we're also going to have negative 2 minus that number. Now, before you go calculating both of those, we don't need both of them. So we're going to go back after we write this down. And we're going to look at, obviously, this one is going to be a positive. This one, of course, will give us a negative number. So if we go back and look at our original equation, we are seeing that we had an x right here. And I cannot take the log of a negative number. We know that the domain for log x is x has to be greater than 0. So I don't even have to calculate the negative answer. So I only need to do the one to the left. And that's going to give us x is equal to 9,999.00005. And I don't have to do that one because I can't have a negative answer. This would be my one and only answer. If you put both answers, it's going to count it wrong. So this next one, we again have 2 logarithms on one side, so we have to collapse it. This time we're subtracting, which means we're going to have log of the first goes in the numerator and the second goes in the denominator. And that's equivalent to 1. So again, now we have 1 logarithm on the left-hand side and no logarithms on the right-hand side. So we're going to change this into an exponential function. So my baby base is 10, that's understood to be there. And this one's much smaller because it's 10 to the first power. And this is going to be equal to x plus 4 over x plus 1. So to solve this for x, we're going to multiply both sides of this equation by x plus 1. So when I do that on the right-hand side, the x plus 1s are going to cancel. Just showing this, you don't actually have to write that term in there if you don't want to on the right-hand side, or that multiplication. So now we're left with 10x plus 10 is equal to x plus 4. And to solve for x, we subtract x over and get 9x. We subtract 10 over, and we are going to get negative 6. So we get that x is equivalent to negative 2/3. Now, you have to take that negative and realize that when I plug these back in, I have to check. So if I take negative 2/3 and I add 4 to it, it'll be positive, so that answer's okay. And then over here, if I take negative 2/3 and add 1 to it, it's also positive. So that is the answer because it takes care of both of those domain values and you don't have any discrepancies. This next one, again, has 2 logarithms on the left, and I'm subtracting. So we have log base 3 of x squared goes in the top, x plus 2 goes in the bottom, and that's equal to the number 2. So again, now that I have 1 logarithm, I'm going to change this into exponential. So I have my baby base of 3 becomes big base 3. My 2 is the exponent, so that goes as an exponent on the base. And that's now equivalent to x squared over x plus 2. So we're going to have, again, the multiplication of x plus 2 to get it out of the denominator. So we have 9 on this side, and then if I multiply that by x plus 2, I have 9x plus 18 is equal to x squared. And we need to get everything to the side where x squared is positive. So I'm going to have x squared minus 9x minus 18, and I set that equal to 0. So at this point, we want to try to factor. So we're asking, are there factors of negative 18 that add up to give me a negative 9? So I've got the 6 and the 3, but the problem is I need negative 18 and I need negative 9. So that's not going to work. So as I look through the rest of them, nothing else is going to work for me. So at this point, I'm going to have to use quadratic formula. So we get x is equal to negative b, which is 9, plus or minus the square root of 9 squared is 81, minus 4 times 1 times negative 18. And then we're going to divide that by 2 times a, which is 2. So as we calculate underneath the radical, we're going to have 9 plus or minus the square root. So we're going to have 81, and then we're going to add 4 times 18 to that, and we end up with 153. And we're going to divide that by 2. So I need to figure out if the square root of 153 is bigger or smaller than 9. So it is actually going to be 12.36. So as I'm looking at this, it's going to be determined based on whether it's big enough. So we're going to have 9 plus that. So we're going to have 9 plus 12.36931, 68769. And we're going to divide that by 2, and we're also going to do the negative. So we're going to do these together. So if I take that and I add it to 9, obviously that's going to be positive, and divide that by 2, we have 10.684, 658, 4385. And if I look at the negative, we end up with negative 3.36931, 68769. So what we have to do, obviously the positive one is going to be fine. So that's definitely an answer. So as I look at this second one, and I'm in the corner of this page, we have x plus 2 is the other log that we are taking. So if I put a negative 3 in there, that's going to end up making a negative number, and I cannot take the log of a negative number. So that answer is eliminated. So the next one looks more complicated, but it's really not, because we have 3 logarithms, all right? So the one on the left is fine. We're going to leave it alone. And then when I look at the one on the right, I know I'm adding. So that means that I'm going to take the log, and I'm going to multiply x times 6, which gives me 6x. Now, the rule says that as long as I have a log on both sides, and I have the base that is the same, then to solve this question, all I need to do is set this equal to this. So we do, in fact, have that situation. So we're going to set x plus 6 equal to 6x. So to solve this, we're going to subtract x over. So I have 5x is equal to 6. So x is equal to 6/5. So that one looked more complicated, but it was a little shorter. And this very last example is very much the same. Just because we have natural logs, they're still logarithms. So I'm adding here. So I need to collapse that down by multiplying x and x plus 4. So I have the natural log of x squared plus 4x on the left. And on the right, I still have the natural log of 3x. And again, I have the same natural log on both sides. Obviously, those bases are the same. So that means that to finish solving this, I just have to set this equal to this and solve for x. So we have x squared plus 4x is equal to 3x. So we have x squared plus x is equal to 0. And now I need to factor. So the first thing I do is factor out my GCF. So the GCF of this is x, and I'm left with x plus 1. And I set each one of those equal to 0. So I have x is equal to 0, and I have x is equal to negative 1. Now what I have to check is to go all the way back up to the original. The original had an x, so that means, and I know from the domain restriction that this x has to be greater than 0. So it cannot be 0, so it can't be that one. And then the other answer, of course, is negative 1. So that one's not going to work either. So this one has no solution. There's no x for which I can plug it into this and end up with a true statement.